Monday through Friday, Max is a practicing lawyer, but in his free time, he vanishes into the wilderness to achieve total off-grid autonomy. Working entirely alone, he has already built an impregnable log cabin. But a shelter is just survival. He wants to turn it into an autonomous base camp. At the center of it all, he will harness the force of a wild stream and construct a water wheel to generate his own electricity, power a handmade wooden washing machine, and grind grain to make his own bread. But the off-grid upgrades won't stop there. He is transforming a raw, unforgiving forest into a self-sustaining machine. And it all begins 200 miles north of St. Petersburg, deep in the Russian forest of Karelia, where he built his cabin. Right now, the wilderness dictates his schedule. He loses hours washing tick-infested clothes by hand, manually sharpening his tools, and climbing a 20-foot tree just to get enough signal to send a message. To replace this manual labor with mechanical power, he begins construction on the water wheel. The first step is sourcing timber, but rather than felling living trees, Max exclusively harvests dead pines left behind by an old storm. The water wheel is a mechanical puzzle requiring exactly 40 boards. Scoops to catch the stream, sidewalls to lock the water in, and spokes to transfer the power. With the rough boards cut, Max hits his first engineering hurdle. To build a perfect wooden ring, the geometry is unforgiving. Every edge must be shaved perfectly flat. His solution is a custom reversible workbench he engineered from a pine log. It allows him to instantly lock any board vertically or horizontally using wooden pegs. This water wheel is only the first phase of construction. Max also plans to build a wooden bridge across the nearby stream to expand his camp, along with a canoe to secure a fast route through the lake to the outside world. Right now, his camp is isolated by a punishing 5-mile trek to the nearest town. Before assembly begins, he must seal the timber. Submerged in water, untreated pine would rot in a single season. To prevent this, he coats every piece in an oil-based wax and leaves it to cure overnight. With the wax cured, assembly begins. To ensure the angles are exact, Max uses a template of his own making as a guide. This is the exact moment where any errors from planing and angling the boards would appear. So far, his geometry is accurate. The scoops lock into place. Now, it's time for the side walls. The wooden blades fit in perfect symmetry. But this ring is only the first step. To actually transfer the river's power, the wheel needs a mechanical drive shaft. Max starts with a fallen log, cutting away the outer layers to reach the heartwood. But out here, nothing is wasted. These outer slabs will later become the wooden gutter that delivers the stream's water directly to the wheel's blades. A square is too clunky to spin efficiently. He fixes this by transforming the timber into an octagon. It is the perfect shape. It removes the harsh angles, making the shaft round enough to rotate freely. He carves 4 deep rectangular holes. This is where the wheel's wooden spokes will firmly lock into place. Back at the camp, it is time to unite the 2 parts, the wheel and the shaft. Once the 2 components come together, the machine finally becomes one working unit. Now Max needs to build a dam, and for that, he turns to the nearby stream. To power the machine, Max needs a waterfall, but the stream is too shallow, leaving no physical room for a water wheel. He digs out the rocky stream bed by hand to create the necessary space, and uses the excavated rocks to reinforce the dam. This simple action solves 2 problems at once. It clears the wheel's path and builds up the dam to increase the water's drop. But a higher dam is vulnerable to spring floods. To safely control the water level, he installs a hollow drain pipe through the dam wall. He carves a wooden plug and seals it with blue clay. Pulling the plug drains the pond. Pushing it in stores the energy. With the water safely controlled, he now needs a way to deliver it. He begins assembling the aqueduct. He retrieves the curved outer slabs he saved when milling the octagonal shaft, and locks the 2 walls together using wooden dowels. The heavy wheel and the water channel need a rock-solid foundation to sit on. Max carves precise mortise and tenon joints to build a heavy frame that will sit directly on the rocky stream bottom, engineered to support their combined weight. But connecting the wooden channel to the dam creates a new mechanical problem. Resting the round channel on the flat dam surface leaves empty gaps where water will simply leak away. Connecting the round aqueduct to the flat dam requires an adapter. First, Max mills a piece of fallen aspen into a square base and anchors it to the dam using wooden pegs. By securing the block first, he gains the stability needed for carving. He hollows out a concave groove directly into the mounted wood. This creates a custom cradle that perfectly matches the channel's contour, holding it firmly in place. Now, he needs sidewalls to funnel the water directly into the channel. The easiest solution would be to pack the sides with dirt. However, Max currently uses this dam as a walking bridge to cross the stream. Dirt walls would quickly crumble under his boots and wash away. To funnel the river, he pins two heavy wooden sidewalls directly into the dam. Inside these walls, he carves vertical grooves that house a flat wooden gate. This simple sliding gate acts as the system's main valve, allowing him to easily regulate the water flow. After a quick dry fit, Max goes back to camp and disassembles the water wheel. Ahead of him, he has the biggest engineering challenge yet: installing the metal pivot pins the machine will spin on. If the pins are off-center, the massive wheel will vibrate unevenly. Hand drilling a heavy log is just too imprecise, so Max relies on a clever trick. He starts by locking a drill bit into a fixed spot, keeping it completely still. The plan is to build a lathe and reverse the rules. The drill will stay completely still, and he will spin the entire shaft against the sharp blade. This will make a hole perfectly centered along the axis of rotation. The lathe is set, and the drill bit is locked. Now, he just has to make the heavy logs spin. Max plans to drive the rotation using an electric drill, but connecting a small power tool to a massive piece of timber is a completely new mechanical puzzle. As the heavy log spins against the fixed bit, physics takes over. By keeping the blade still and spinning the wood, the hole is forced to carve perfectly straight down the middle of the shaft. But once the first metal pin is hammered in, he can no longer attach the power tool to that end. To drill the opposite side, he must change his technique. He cuts a rubber belt from a scavenged tire and wraps it around a pulley mounted on the shaft. By pulling the belt, he rotates the heavy log by hand. It is a primitive setup, but it works perfectly. He hammers in the second pin and presses the shaft back into the wheel. Now he can finally spin the wheel and see whether it runs cleanly on its supports. It glides perfectly. The primitive lathe was a complete success. With the wheel finally back at the river, Max needs a secure mount for the spinning shaft. He carves two solid wooden blocks to act as bearing housings. These will support the metal pins and lock the machine firmly into place. This pulley is crucial. It will act as the main drive for all his future machines. But for the wheel's power to be transferred efficiently, the pulley has to run straight. He positions a dial indicator against the spinning wooden edge to check for axial and radial runout. He carefully taps and shifts the pulley's position, adjusting it until the needle holds dead still. Side fixations lock the pulley permanently in place. The machine is finally ready for the river. The water wheel works flawlessly. Now, it is time to harness the river's power. And the first thing he will use it for is to make bread. Months earlier, Max recreated an ancient farming technique: slash and burn agriculture. He cleared a small patch of wild land with a controlled fire. Using the nutrient-rich ash to fertilize the soil, he created a perfect spot to plant wheat. Now, he brings that harvest back to the river, ready to use his new machine to grind the grain and make his own bread. With food secured, Max faces his next relentless problem. The woods are swarming with ticks. Washing his infested clothes by hand in freezing water is a miserable chore that wastes hours of precious daylight. To solve it, he has engineered a custom wooden washing machine that will be powered by the river. But his design hits a hurdle. The spinning mechanism needs a perfectly round wooden hub to handle the intense friction. So, Max must first build a fully functional wood-turning lathe right in the middle of the forest. The pedal creates a simple back-and-forth rhythm. With both hands free to hold the chisel, he can finally shave the rough wood down into the round piece he needs. This carved cylinder acts as the main anchor for the central steel axle. It will allow the washing cage to grip the metal tightly, so they spin together without slipping. With the grain grinder disconnected, Max swaps in his new washing drum. He links it straight to the water wheel's pulley, ready to let the river test his latest build. Washing clothes in the wild marks a real turning point. Until today, every tool was built just to cover the basics. Now he is ready to build something that goes far beyond basic needs: his own electricity. This is where the setup gets truly clever. By connecting an ordinary electric screwdriver to the spinning drive, Max reverses how the tool works. Instead of draining a battery to spin the motor, the river spins the motor to create electricity, feeding a steady charge directly into his external battery bank. With an endless supply of electricity, climbing this tree just to send a text is a thing of the past. Max scales the branches one last time to mount a signal booster. From now on, the river itself powers his connection to the outside world. But the water wheel's versatility doesn't stop there. He also crafted a grinding drum that slides right onto the shaft. This will automate an essential camp chore that used to cost him hours of sweat and physical labor. With the water wheel fully operational, Max is forced to face the next hurdle. The same stream that powers his camp also prevents him from expanding his off-grid settlement. He needs to cross it effortlessly on a daily basis. For that, he wants to build a 35-foot wooden bridge. If he plants a support pillar in the middle of the stream, the first spring flood will wipe it out. And a flat bridge of this size would snap right in two. Arches are the secret. They transfer the entire load directly into the riverbanks. This creates an indestructible foundation without driving a single pillar into the current. To form it, he mills long planks and forces them into shape over a wooden mold. Layer by layer, they are bent and bonded into a single solid arch. To build the flat deck of the bridge, Max needs serious length. He manages to find fallen timber long enough to span the river and immediately gets to work. To protect it from years of weather, he finishes the timber with pine resin. With the bridge complete, Max takes a rare moment to breathe. He clears debris from the stream that, if left unchecked, would block the water from reaching his dam. In the quiet forest, he makes a new friend, a fox. He decides to head back to the cabin and share some eggs with it. But he needs fuel too. His next ambition is to craft a wooden canoe, his new transport line. There is just one problem. The grueling labor of milling the bridge has taken a severe physical toll. He has developed a tennis elbow, a painful inflammation of the tendons. The canoe build will demand milling more timber boards. To save his arm and make the build possible, he has to come up with a plan. Max starts with a logical approach. He mounts a straight guide rail directly onto the log. The idea is to slide the chainsaw smoothly along the track. But the vibration makes the saw difficult to control, sending sharp pain straight through his injured elbow. To force the blade to stay level, he needs a dead weight that pins the saw to the track. It keeps the cut straight, but pushing the heavy rig is still tearing his elbow. The challenge is clear. If he can't push the saw has to move itself. Max has to completely rethink the mechanics. He attaches an elastic cord to the carriage through a simple winding system and creates something unique. The self-propelled sawmill provides the precision to cut thin, flexible boards he can bend and curve. The construction of the wooden canoe can officially begin. The timber planks aren't wide enough to form the side walls of the canoe. He must join two boards edge to edge for each wall. Fusing them requires pressure, but out here, he has no clamps. To fix this, he builds a primitive wooden vise right into the forest floor. By wedging a heavy beam between four short pegs, he locks a log completely still, allowing him to carve a sharp spike. Driven deep into the earth, these spiked posts serve a critical purpose. They act as vertical clamps, holding the two boards in place, ready to be joined. To fuse them together, he uses wooden dowels and a thick layer of waterproof glue. But glue alone isn't enough. It requires crushing pressure to bond. For that, he improvises some simple wedges. Driven in one after another, they tighten the seam, gradually pulling the boards into full contact and keeping them there until the glue sets. While waiting for the boards to cure, he shifts to building another essential tool. He carves sawhorses straight from the forest's logs. Lined up together, they create a makeshift assembly station to support the long canoe frame and continue the build. One of the walls is dried and finished, but a boat needs two. The process needs to be repeated for the opposite side. Back in civilization, Max lives a completely different life. He wears a suit, works in a city, and fights battles in a courtroom. But out here, nature doesn't care about your job title. You can only rely on your own two hands. For him, this is about testing himself. To use his own mind to conquer nature and build a totally autonomous off-grid settlement. He finally has the two side panels ready, but right now they are just flat boards. To turn them into a canoe, he first has to shape them. What follows is a very old boat-building idea. He joins the two side panels first at the bow and stern, using solid wooden blocks to lock in the length and alignment of the boat. That is what makes the next step possible. With the ends fixed, the middle can be forced outward under control. He forces beams right into the middle, pushing the flat walls apart. The straight timber has no choice but to bow outward, instantly forming the curved belly of a canoe. The hull is bent, but the ends are rough and the bottom is uneven. Max marks precise guidelines along the base and the final joining points, where he will make cuts and refine the canoe's shape. After taking the frame apart, he can make the cuts safely. With the ends refined and the bottom line established, the hull is ready for the next step: the ribs. In any wooden boat, the ribs act as the internal skeleton. They are curved pieces of strong timber that cross the inside of the hull. They lock the bent walls in place forever. and give the boat the strength to survive the crushing pressure of the water. They have to line up perfectly, or the hull will twist and the boat will pull to one side in the water. To prevent this, Max uses an ancient builder's trick. He stretches a tight cord directly through the center of every rib. This simple string creates a perfect center line, guaranteeing the entire skeleton is completely straight. The boat will be a simple, shallow canoe, big enough to feel stable on the lake, but still light enough to carry. About 15 feet long, built for the dark waters of Lake Ladoga. But the bottom of the boat is still wide open. The hull needs to be sealed. The ribs hold the walls together, but the boat still needs a spine. Max joins two long boards to create the keel. Running straight down the center, this beam acts like a blade, forcing the canoe to cut a perfectly straight path through the water. He first tapes over the seams, so the bottom will not glue itself to the hull yet. The screws will hold the bottom in place temporarily, while he checks the fit and works on the final shape. The days of hiking for hours to civilization and back are almost over. If the water test goes well, this canoe will change everything, turning a punishing hike into a smooth, fast glide. The lake will become his new highway. The boat is fully built, and Max designed it completely modular for a reason. If the bottom ever rots or smashes against a hidden rock, he can simply unscrew it and build a new one without losing the entire boat. Before the launch, the hull must be completely sealed and waterproofed. Instead of buying chemicals, Max uses a mix of rosin and turpentine, which are a natural hardener and waterproofing chemicals found in pine roots. To extract this resin, he designs a homemade distillery. The principle is simple. Cook the wood without burning it, collect the resin, and turn it into waterproof protection. The raw resin is thick, so he thins it with gasoline at a 1-to-1 ratio. This chemical trick will force the liquid deeper into the dry wood. Once brushed on, the gasoline evaporates, leaving behind a hard, non-sticky shield that protects the vessel. After a quick break, and with the paddle carved, the canoe is ready to hit the lake. Max arrived in this forest with basic tools. Since then, he has raised an off-grid cabin from dead timber, harnessed the river to build a working water wheel, and engineered a modular boat to secure a fast transport line to the outside world. Shelter, power, and transport are secure. Now, he can spend more time making upgrades to live more comfortably and experiment with a self-sustaining food source. His next project, installing a cheap, transparent beehive built entirely from plastic bottles. He has been refining the method for years, even at home. One bottle holds the nest, another takes the surplus honey, and it can be removed without opening the brood nest. Replicating this at the camp would be a major success. In the wild, a hive only works if it can shelter the colony without exposing it. It has to insulate, conceal, and disturb the bees as little as possible. But here at the camp, the real test will be winter. So he pushes the experiment one step further. He buries one hive underground and lets the earth do the insulating to see whether the colony can survive a Karelian winter on its own. By this point, Max has built enough structures, machines, and inventions that the tools themselves have become a problem. There are simply too many of them, spread across too many corners of the camp. So the next improvement is not another machine, but a proper storage system. He starts with a log that was too irregular for the cabin walls, but still far too good to waste. Cut into thick slabs, it becomes storage instead of firewood. The joinery follows a proven method. Pegs and holes lock the parts together without relying on delicate fittings. The legs angle outwards so the footprint grows larger, giving the frame the stability it needs. But the rack is not finished when the shelves go up. It only starts working once each tool has a place of its own. A sheath for the knife, a slot for the big two-handed chisel, and what was once clutter starts becoming a workshop. With the tools under control, Max turns to utilitarian furniture. His camp is now a functioning homestead, and the time to get back to civilization is getting closer. The canoe floats perfectly, but his severe elbow injury makes rowing back to society out of the question. To survive the journey, he must rely on the wind. Max plans to upgrade his boat into a sailing catamaran. Relying on the wind means higher speeds and less precision. One wrong gust can slam the hull into hidden rocks. Before raising a mast, he must armor the boat. He starts by adding rub rails, sacrificial strips meant to take the first damage when the boat scrapes stone or hits a hard landing. They are bent into the shape of the hull under force, and that built-in tension gives the strips a tighter hold, while adding strength to the structure. A sail can replace muscle, but it also introduces a force the canoe was never built to handle. A shallow hull has no ballast, no weight below the waterline. Without that resistance, the same wind that drives the boat forward can also roll it over. He needs a catamaran, and for that, he needs a second hull. He brings out an old plastic kayak. It is only a test platform. He needs to calculate the perfect width between the hulls and understand how the wind will stress the frame. He selects maple for the crossbeams. The frame must absorb violent twisting and heavy wave impacts. A weaker wood would simply snap. He lashes the frame to the canoe with wire. To protect the hull from the razor-thin steel, he drives metal liners into the wood. The binding must hold tight without destroying the boat. He adds a steering oar bracket, a simple support that can hold an improvised rudder in working position. This will give the boat control. He also locks the deck anchors in place. This is where the ropes of the sail will tie down. These metal points are critical. When the wind hits, it tries to tear the mast right out of the hull. Every anchor must hold the ropes tight, or the entire rig will collapse. With the frame tied down, the rig in place, and the canoe finally able to carry sail, there is only one thing left to do: take the experiment onto the water. As soon as Max is adjusting the sails, he notices something on the water. It seems like driftwood at first, but it's a small shape fighting the surface. A wild duck, trapped in an old fishing net and slowly being pulled under by it. It was minutes away from drowning. For Max, moments like this explain the larger logic of everything he builds here. The aim is not to conquer nature, but to thrive within it. The temporary kayak has served its purpose. The frame carries the load, the rig works, and the boat proves the idea works on the water. Now Max can commit to the real build and start making the proper second hull for his sailing catamaran. That brings him back to the sawmill he invented when his elbow first began to fail him. Under sail, when the wind pushes sideways into the rig, it gives the boat a strong rolling force. His shallow canoe would want to lean, roll, and eventually capsize. So the boat needs another point of support out on the water. The extra hull will give it that support and turn a shallow paddling canoe into a sailing catamaran. The second hull follows the same basic logic as the first boat, but this is not just a repeat of the exact same build. The engineering is the same, but the purpose is different. This hull is narrower on purpose. Its job is not to carry the main load of cargo or body weight. Its job is to add support while keeping resistance low. In other words, it gives the sailboat stability without paying too much for it in drag. The fit in the final pieces is not perfect. Apparently, his injured elbow has made precision harder to hold. So he uses a centuries-old sealing method and caulks the seams with cotton rope. Packed into the gaps, the fibers swell when wet and help make the hull watertight from the inside. He planes the bottom into a true flat surface. The second hull will use one single bottom board. To finish the second hull, he seals it with resin. Then he reinforces it with rub rails, just like on the main hull. The kayak served its purpose by proving the concept, but its role is now complete. It is time to bring both hulls together into one structure. The catamaran is finally complete, but a dry test means nothing. The true judge is the lake. The wind catches the sail, and the double hull glides effortlessly across the lake. There is no more physical strain, just the gentle pull of the wind doing all the work. He steers the catamaran back to camp. His tools and supplies are waiting. It is time to pack his gear and return to civilization. He stepped into this forest with bare hands and a vision. Slowly, he reshaped the wild. He turned fallen wood into a fortress and made the water and the wind work for him. This is no longer just a basic camp. He has now built a true home. Before the journey out, he cooks a final meal, fuel for his long trip back. He will return next year, but not for more heavy labor. He will come back to finally enjoy the masterpiece he has created.